Hi thinkers, welcome to ThinkX Academy. In this machine learning playlist, we are going to understand now what are artificial neural networks and how we can use neural networks to detect some objects around us and for speech recognition and for text recognition, and there are various applications of neural networks. So far we in this playlist we have studied a lot of learning algorithms like linear regression, logistic regression, and these learning algorithms are too simple to handle so many features which are required in doing the object detection and some other problems also. So neural networks or the artificial neural networks solves that problem, and we're going to address that problem. All right, so now you can see that there is an image on the screen here, and this image we know that this is of a mango, right? So this is a mango. So now what we're going to do is we're going to see how humans actually recognize objects around us, and then we're going to see that how a neural network in a similar fashion, how a neural network will recognize that object. And it is really fascinating to know that neural networks, the artificial neural networks, are actually motivated from the neural networks inside of a human brain, right? So let's see how we will see how humans will interact with the objects around us to understand what the object is of, and then we will see how the neural networks or the artificial neural networks will understand this object. So this object is of a mango, and we know that this is a mango because for several years we have seen a mango, we have tasted a mango, we have seen different types of mangoes, and people are speaking about mangoes. So we actually know because we are trained, and since we are trained, we know that this is a mango. But let's consider that there is a child here, right, which is, let's say, 3 or 4 year old child, and he has never seen a mango in his life. So what I will do is I will take a mango and I will show this mango to him, right? And I will ask him, can you recognize this object? Then he will say that I do not recognize what this object is. Then I will say him that this is actually a mango. And after saying that, he will just see this picture or the object with his eyes. So basically, eyes will capture the images of the object, the texture of the object, and he can even touch this object, right? He will touch the mango and he will see the shape and texture and different features of this object. And then I will tell him that actually this belongs to, these all features belong to a mango. So this is basically a mango. Now, after some weeks, let's say after 3 to 4 weeks, I will again take, let's say we take this child to some shopping mall or a market, and in the market he again sees this object or a mango, but again he tries to remember what this object is, but he does not remember that because he has only seen it for the first time. Now when he goes to the shopping market, he will see this object, which is this mango, and then after this he will ask, I do remember what this object is, but uh, I do not actually remember the name, right? So we will tell that actually this is a mango, right? And similarly, after years and years, this child will become trained because the neural networks inside of this child's brain will recognize this object, so that whenever he will see this object, he will be able to understand that this is a mango. Now, this is how humans interact with different objects and understand what this exactly is. Now, instead of a mango, it can be some words, some text, some voice, and like this, or some face. So you can see that there are different industries which actually use neural networks. For example, let's take an example of Tesla, or let's say Google. We all have used Google or Siri uh, to actually give voice commands to them, and you can see how much fascinating it is that they can actually process our voice and give answers related to that. Now, this is because these are trained neural networks and they are so deep neural networks that they can actually understand your voice. Now, Tesla uses the object detection neural networks, and it is so much precise that in their cars they have enabled this object detection, which basically gives, or actually it makes the cars as the self-driving cars. Right, so this is enough motivation of what is the actual scope of the neural networks, the artificial neural networks, and you can see how much essential it is to understand the basic idea behind neural networks. Alright, so this is the human interpretation of objects. Alright, so let's see how we can actually convert this human interpretation of objects into the artificial neural networks. So the first thing is we will first collect some of the images of this object. It can be any object, or in the case of text classification, it will be some text. So we will create some, we will create it, or we will have some data set which contains all the images with some aspect ratio. Let's say this is a 64 by 64 pixels, and here we will have all the images with the same aspect ratio, and we are going to supply these images to the neural network in the input layer. So the neural network starts with the input layer, we have where we have some nodes, or these nodes are basically the input layer. Let's say we have three nodes and we have input layer, and in the neural network we have this first layer where we will pass all the images. These are basically the images of mango, and we will pass these images as a vector or as a matrix, in the matrix form or in the pixel form, to this input layer as x1, x2, x3, right? So this is the input layer where we just supply the input values to the neural network, and from here only we are going to actually, now the neural network will use this input layer to do the further evaluation, which is the hidden layer. So after getting all the inputs, now it will move to the hidden layer. In the hidden layer also we have some nodes, and let's say we have four nodes in here. What happens in the hidden layer is that we apply some matrix transformations in the input layer, and using that we will basically parse it to the hidden layer nodes. For example, let's say we have x1. We are going to make a channel to this node of the hidden layer, and we will make another channel to this another node, and we will do it with all the nodes like this. And while making these channels, we also assign some weights to these channels. Let's say this is weight 1, weight 2, weight 3, and weight 4. Now, in the hidden layer, which is the second layer of our neural network, we actually try to make the nodes after making some channels from these inputs, and we apply some weights to these inputs. Although these weights are not fixed, these will actually get adjusted to make our prediction more accurate, which we will see later on. But here what we are doing is we are actually making a channel to all the nodes of the hidden layer with the weights, weight 1, 2, 3, and 4. And now what we will do is we actually try to multiply the operation is x1 multiplied by the weight, which is weight 1, and then we add some bias to this, and after calculating this we will also calculate for weight 2, so it will be x1 w2 plus some bias, and after adding that we will get these nodes in the hidden layer. Let's call them as B1, B2, B3, B4 and something like this, right? So the same thing will happen with all the nodes of the the input layer. Again, the X2 will make a channel to this one and this node and this node, and similarly with all the nodes it will make a channel. And here also we will have some nodes, some weights of these channel, right? And similarly for the X3 node we will also have some channels with some weights. Now we perform this operation, which is x1 multiplied by the weight, and we add some bias and we get this hidden layer. There can be more than one hidden layer also. Let me enclose all these nodes in a single layer. So now what we do is, in the hidden layer we calculate the bias, and there can be some more layers, and we again will make some more channels to those nodes, and we will again perform this operation. But let's consider that we have only one hidden layer. Now what we do is we finally have the output layer. So this is basically the hidden layer, and the final layer of our neural network is the output layer. Now in the output layer we have all the classes or outputs that we want that we want our neural network to predict. In this case, which is we are predicting a mango, so the output will be can contain only two outputs or two classes, which is of a mango or not a mango, right? So here I will make a channel to the output layer like this, right? And like this, I will make all the channels in the same manner, and we will get the output as a mango or not a mango, right? So this one, let's say this one represents that it is a mango, and let's say this one represents that it is not a mango. Alright, so these are the basics of a neural network. We supply the images to the input layer, we apply this operation by adding some bias to the hidden layer, and then we will get the output, and the output will be a mango or not a mango. But this is not the end of the case, because in the first iteration you may get a wrong answer. So let's say I supplied a image of a mango, but after calculating these bias and weights, it predicted that it is not a mango. Let's say it predicted in the output that it is not a mango. Now in this case, if it happens, so what we will do is we will tell the neural network, actually we can create a table of actual versus predicted values. So let's say the neural network has predicted that it is not a mango, but actually it was a mango, right? So what we will do is, when the prediction is wrong, what it will do is it will back propagate to the input layer. It will do the back propagation. I'm going to write here back propagation, right? So it will back propagate to the input layer, and it will adjust the weights. It will adjust the weights, right? It will adjust these weights, weight 1, weight 2, weight 3, and all the weights of all the channels. And how will it adjust is, what we will do is we will tell the we will act in this table, we will tell the neural network that there is some change in error, right? So I can actually create another column. I'm going to create in the down here, and here you can see I have created another column which says that the error between the prediction and the actual is let's say plus 0.5, plus 0.6 or minus 0.4 and so on, right? So for different iterations I have different values of error. So here you can see it, the error is plus 0.5. so it will use this error to actually adjust these weights, and on adjusting these weights it will be able to uh, make the prediction more accurate, and that's how it improves the accuracy, right? So it improves the accuracy. So after seeing the errors that are coming, it back propagates and it adjusts the weights according to the error that we have supplied, and then it will again make a prediction, and then again we will check it with the table. The more time we do this, we call this as training, the back propagation. And you can see initially it was going like this, which was the forward propagation. So the forward propagation and back propagation is basically one cycle, and the more these cycles are, the more will be the accuracy of our neural network. So this is basically how we train a neural network to make predictions, and the more a neural network is trained, the better it will be able to predict. Same as with the you can see in the example of a human also, the more you will see an object and the more you are introduced to that object, you will be able to make a better prediction. One more important point here is to understand which is something known as activation function or a threshold function, right? So an activation or a threshold function can be a sigmoid function. We have studied sigmoid function in the logistic regression. This function basically converts any supplied value to 1 or a 0, right? So in activation function, what this activation function does is it actually activates or deactivates a particular node in the hidden layer. So let's say I want to calibrate the weights. The reason why the activators are used is because in some cases we actually want to hide some nodes. Let's say we want to hide B2 nodes. So what this activation function will do is we will supply it with some value that it will actually give me the result as 0, and 0 means that the node is actually deactivated. Sometimes this activation function is also known as the threshold function, and it is basically just used to activate or deactivate some of the nodes so that it will be able to make some better predictions. Instead of sigmoid functions, there are a lot of different variety of functions that are used for activation. So basically when we introduce activations inside of a neural network, you can see we introduce some non-linearity inside of a neural network, because these functions are non-linear in nature. You can see this is a non-linear function, and with the evolution of and advancement of technologies in the neural networks, it is quite observed that different choice of activation functions are there. For example, currently ReLU is a threshold function which is actually more reliable than a sigmoid function because it has limitations too. But it will be an advanced topic, and here we are just covering the basics of neural network, of how it works. So now we actually know that how a neural network will take the images in the input layer, add the weight, multiply the weight, add the bias, and use the activation function to activate or deactivate the unnecessary nodes, and then compute the output as a mango or not a mango, or we can have some more outputs as well. So that's how a neural network does a prediction. Let me give you an example of a real life example of how neural network is working inside of Microsoft PowerPoint. I will go on insert, and here in equation I will go on ink equation here, and now you can see that I get this dialog box. Let me expand it, and here you can see if I will try to write something here, let's say I write an equation x square plus y square is equals to 2. So you can see that I'm writing this whole equation in my own handwriting, and since this is an already trained artificial neural network, this whole equation is being recognized as x square plus y square equals to 2, which you can see is 100% accurate. There are some cases where it will go wrong, like let's say I will write a summation sign and I equals to 1 till n. It will be able to do that, but in some cases it fails to understand what actually I'm writing. So let's see here. Let's expand this equation. You can see that when I'm writing this, we know that it is yi minus x, but you can see it is not that much accurate. So basically this is a trained neural network, and for most cases it will work, but it is not 100% accurate also. But it is a good example of learning how actually this is converted into this equation. And what actually is done is, you can see there are some boxes here. You can, if it is visible to you, you can see that there are some boxes. Now what these boxes do is, they are being supplied to the neural network as an input layer, and when you will supply them in the neural network will do the processing as we have already studied, and it will be finally give us these results in the output layer. So that's all for this tutorial. If you have liked the video, please make sure to like this video, share this video with your friends, and subscribe our channel to support us. Thanks for watching.